Hey scientists, Brady Bill here. This week in the ology Science Club, we channeled our inner maverick as we learned all about the science of flight. Let's check it out. If you want to understand flight, there are four basic forces involved. Of course, if you're trying to get something off the ground like an airplane or a rocket ship or a hovercraft, the most important force on your mind is gravity. Gravity is a force that we feel pulling us down towards the earth. And so if we want to get something off of the earth up into the sky or even into outer space, we have to have a push force to counteract that. We feel gravity as a pull force. It pulls everything down towards the earth. And so if you want to get something off the ground into the sky or even into space, you need to give it a counteracting push force called lift. And as you move through the air, whether you're moving up or side to side or forward and backwards, you need a way to do that. You need a push force that's going to propel you through space. That force is called thrust. In an airplane, the engines provide thrust to push it forward so it can get lift off of the ground. In a helicopter, we'll see that the thrust is actually in a circle. It spins in a circle. And of course, in a rocket ship, the thrust is going to point the same way as our lift. It's going to point up into the sky. And as you move through the air, you are going to encounter millions and billions and trillions and trillions of air molecules, and they're going to push back against you, and that is called drag. So in whatever direction you're moving, that drag is going to be pushing back against you. Of course, until you get into outer space where there are no air molecules. The first project we worked on this week was a world record-breaking paper airplane. Now, if you folded one before, it probably looked a little bit like this. This is a dart-style airplane. It's made to be very long and slender so that it doesn't encounter a lot of resistance, a lot of drag. It's meant to go very fast. But these don't go very far necessarily because it's hard to get lift under these narrow wings. So we worked on a glider plane that's going to catch a lot of lift and is going to get way up in the air. I'll show you how. First, you want to give your piece of paper a hot dog on fold. In other words, fold it in half the tall way. Make sure your corners match up nicely. And give it a good crease. Next, you want to grab a pen or a marker and make a little dot about 1 inch down from the top of the page, right in the middle where that crease is. Then you're going to fold both top corners over until they touch that dot that you made right in the middle. If you've done it right so far, you should end up with what looks like a superhero cape. Then you're going to fold the top of the plane down, and you want the crease to be right where those two pieces of paper come together. So you're going to fold it down, give it a good crease. All right, then you're going to repeat that step 5 more times, folding over and over and over.
1, 2, 3, 4, 5.
Now you might need to smooth some of your edges out again. And when you're done, you should end up with what looks like an envelope with kind of slanted sides like this. Then you're just going to, where that crease is that you made already, you're going to fold it right up in half. All right. So now, where all this paper is bunched up, that's going to be the front of our airplane. So I'm going to close it up, and I'm going to set it on its side. You can see the crease now is on the bottom, and the open end is on top. This is where we're going to have to fold down our wings. So we're going to pretend there's a line running right along the bottom here, parallel to the bottom. We're going to leave enough room for us to hold the airplane. And we're going to fold one wing down flat, just like that. Give it a good crease. And so this is what we've got so far. We're going to pick the whole thing up, flip it over, and we're going to fold down the other wing. And there you have your glider plane. You can hold it on the bottom. Here's the top. It's going to grab a lot of air underneath, and it's going to get a lot of lift. The next flying machine we took a look at was a helicopter. These are helicopter blades, just like on a real helicopter. And you see, they're slightly tilted, so that as we spin the blade, the air gets pulled underneath. In other words, the thrust here is actually pointed in a circle. And as it spins around, it's going to scoop the air up underneath the blades. Now, we also learned that because of its shape, you can only spin these in one direction. If you spin it the wrong way, then rather than the air going under the blade to give it lift, the air will actually push down on the top of the blade, and it will go down in the ground or into our hands or even into our faces. So we got to be careful. The best way to fly these helicopter blades is you're going to hold it in your left hand, and you're going to use your right hand to get it spinning. You put your right hand right there, put your fingertips there, and then you give it a push. Pretty cool, right? Finally, we talked about one of my favorite flying machines. We talked about the rocket ship. Now, we actually took this outside and saw it launch high in the air, being propelled or given thrust by air. We pumped it up with a bike pump, we released all of that air pressure, and it shot high into the sky. But the one that we took home was a little bit different. We didn't power our take-home rockets with a bike pump or even with hot gases like you see on TV. Our rocket is powered by a burp. So this is what our rocket looked like. You can get these film canisters on most major online retailers, and they're literally just a small canister with a lid that fits on very tightly. And to get our burp, we're going to use a little bit of burp medicine. This medicine right here is basically baking soda and vinegar, or the same kind of reaction. And if you take out a tablet and you put it in some water, it very quickly reacts to form carbon dioxide gas, those bubbles. And what we want to do is create gas pressure. We want to build up those bubbles inside of our rocket until all of that pressure releases at once, kind of like a balloon popping, except in this case, it will be a rocket flying. Now, this particular demonstration does come with a safety warning. First of all, you want to make sure that you have a lot of overhead space. Don't do this somewhere with really low ceilings, and especially make sure that you're not doing it right under a light bulb or a kitchen chandelier, ceiling fan, something like that. Outdoors is best, or just a room with really high ceilings, and you'll see why in just a moment. The second safety warning is, as you're doing it, once you have put the rocket in place and the medicine is inside, you want to take a nice big step or two backwards. You don't want to have your face right over the top of it, and you don't want to have your eyes right level with it, because when it goes off, it might spray some of that bubbly water out, and you don't want to get that in your eyes or in your mouth. So please observe safety while you try this at home. So, to launch our burp rocket, it only takes a half a tablet of effervescent medicine. So we're going to break this in half. You're going to have enough in your kit to do 4 launches. And we're going to fill up our burp rocket about 1/3 full of water. Not quite halfway, because we want to leave plenty of room for that gas to build up inside. Once we've got our water in the chamber, we're going to take our half a piece of burp medicine, drop it into the water. We're going to quickly and tightly seal that cover up. We're going to put it upside down on our plate or in the sink, and then we're going to step back and we can begin our countdown. 10, 9, 8, 7. Whew. Maybe you can start your countdown from 5 instead. That points out something interesting, because remember, this year we're thinking all about variables. So what can we change about this experiment to get a different result, to get a faster launch or a slower launch, a bigger launch or a shorter launch? Let's think of some of the things that we can change. First of all, we could change the amount of burp medicine that we add. If we add more burp medicine, are we going to get a bigger reaction or a smaller one? And then another one we can change, of course, is how much water we put into the chamber. We already said we don't want too much water, but what if we did fill it almost all the way to the top with water? How would that change the result of our launch? And then there's one bonus one that we didn't try in class, and that is, what would be the difference if you use hot water or warm water versus cold water? Will you get a faster or a slower reaction? Will you get a bigger or a smaller reaction? That's something you can try at home. So that's it for this week. I hope you had a great time learning about flight science. I will see you next week in the Woology Science Club. Do more science, have more fun.